Tic-Tac-Toe project. We were Team 9, and Team 9 included Christian Berreneau, Miguel Lorraine, and Near Single. In Computer vs. Human, where the computer goes first, our first move was always top left. We went top left to eliminate a large portion of the different scenarios. From there, our next move was based off the human's move. After the human's move, we would always try to force a winning move where our functions would take over. Our functions included a winning move that always tried to find a winning move and a block function that always tried to block a human's winning move.
In Human vs. Computer, where the human goes first, we used the human first function, which was considerably longer than our other functions. We had to take into account a larger number of possibilities where the human goes first. In addition to our win and block function, we implemented another move function named the eighth move function. This function scans the board and determines whether or not there's an X or no on the given spot. If there is not, the function will automatically place a marker there in order to tie the game. For the block function, we used for loops and a counter to determine whether or not there was a move that needed to be blocked. The way this function works is that for each row, column, or diagonal, the function will count up the number of consecutive X's or O's. If the counter is 2, the function will automatically place the opposite marker in the empty slot, thus preventing the opponent from winning.
As you can see in the block example, the human's X's and the computer's O's. The human has a winning move, but with our block function, it automatically blocks the winning move. For the win function, we use for loops and a counter to determine whether or not there was a move that could win the game. The way this function works is that for each row, column, or diagonal, the function will count up the number of consecutive X's or O's. If the counter is 2, the function will automatically place the markers in the empty slot, thus winning the game. Here's an example of how our winning function works. As you can see, the human's X's and the computer's O's. The computer had a winning move, but the humans missed the winning move and placed the marker somewhere else. Thus, the computer was able to win with the winning function. For scanning the board, the sensor is going to scan the middle column first, and then it is going to spin and then scan the edge pieces, and then it will spin again and scan the corner pieces, and then it will reset to its initial starting position. It spins because we have to adjust the taco limit. By doing this, many problems occurred because we did not have the same robot every day. Finally, as we were writing the function, we used for loops to scan the board, and if there is a blank space available, the sensor will output black, which will output the board as a hyphen corresponding to that spot. If it's blue, it will output the move as a taken spot with an O, and if it is green, it will output the move as a taken spot with an X.
For placing the markers, we used our row move function, which accepts the move as its input. The way this function was written was a series of if statements that changed the tackle limits of the arm and spin motors. For instance, if the move is 1-1, the board will turn first 135 degrees, then the arm will move forward 100 degrees, and then the third motor will drop the ball. After this occurs, we implemented another function called row move reverse, which is essentially the exactly same as row move. The only difference between the two is that row move reverse has negative power, and there's no need for the third motor to drop the ball.
Essentially, our program is a bunch of functions within functions. We chose this method in order to avoid programming the tens of thousands of possibilities. Our win and block functions were essential for this to occur. While we needed to hard code some of the possibilities, these functions made our program much more efficient.
All right. Here we are covering our robot because color sensor doesn't work. Okay. Here's the motor. Color sensor. It's scanning.
Way to go, General.
All right.
We made this more challenging than it needed to be by having not enough robots, not enough batteries, time.
I think they just don't think stuff.
And the motor does not work anymore.
I decided to do it.
Just go working. And okay. That's gonna be all right. It's just like.